Disentangling causation from mere correlation is one of the main jobs of an empirical economist. It tends to be relatively easy to recognize correlations in the data, but it's much harder to uncover the causal story behind those correlations. In 1988, a Harvard University dean interviewed a bunch of Harvard freshmen. He found that the students who'd taken an SAT prep course, on average, did worse on the SAT than those who didn't take a course. So the dean looked at his data and concluded that SAT prep courses were not just unhelpful, but actually harmful to student scores. The prep courses caused students to do worse on the exam. But wait a second. Let's think about some other possible causal stories the dean's data might be telling us. The prep courses might have caused lower test scores. That's the dean's interpretation of the data. But maybe students with a lower test-taking ability were the ones signing up for the prep courses to try to catch up. In a sense, the lower test scores caused the students to want to enroll in a prep course in the first place. Or maybe there's some other factor that plays a role in both the student's test score and her decision to take a prep course. For example, maybe nervous people like to take prep courses, and nervous people do worse on tests. In this interpretation, the course doesn't cause the low score, and the low score doesn't cause the student to take a course. Instead, it's being nervous that causes both. The point here isn't that the dean is definitely wrong. Maybe the test prep courses really were just awful classes that lowered the SAT scores of all the students who took them. The point is that we just don't know what the causal story is if all we have is a correlation between prep courses and SAT scores. So what can we do to figure this out? One of the most powerful tools researchers have is the randomized trial, the gold standard of testing for causality. Randomized trials involve taking a group of volunteers and randomly assigning them to either a treatment group or a control group. The people in the treatment group receive whatever it is we're studying. In this case, we'd enroll all our students in the treatment group in a test prep class, and the people in the control group don't get anything. How does this solve our problem from earlier? Let's consider what we'd ideally like to do to figure out the effect of these prep courses on SAT scores. We'd like to take a group of students, clone them, and place the originals and the clones in parallel universes. Everything would be the same in these parallel universes, except in one of them, the students are all in test prep classes, and the others, they're not. Then we'd look at how each set of students did on the SAT. Since everything about these students are identical, except for that prep class, any differences in scores must have been caused by the class. We can tell our causal story. Unfortunately, we live in the real world, unable to clone students and spin off parallel universes. But all is not lost. With randomization, we can approximate this alternate reality experiment. Because assignment to treatment and control groups is not determined by anything about the subjects, but by the flip of a coin, the treatment group is going to be virtually identical to the control group in every facet but one. The treatment group gets the test prep class. The past decade has seen an enormous surge in the use of randomized trials to address some of the most important issues facing developing economies. This has been driven in large part by the efforts of the MIT Jameel Poverty Action Lab, or JPAL, founded by Professors Esther Duflo, Abhijit Banerjee, and Michael Kramer. In 2019, the trio won a Nobel Prize for their work with randomized trials. One influential JPAL study looked at a program in Indonesia that provided subsidized rice to households in the bottom 25% of the income distribution. A major challenge for such anti-poverty programs is targeting the benefits to those that need them the most. In Indonesia, only 1/3 of eligible households were receiving the rice they were entitled to. Meanwhile, many ineligible households were managing to receive much of the rice. Researchers set out to test a simple, low-cost solution to the problem. They would provide a card to households to clearly identify their eligibility. Could such a seemingly small intervention really matter? This study aimed to find out. The researchers randomly selected 378 villages to receive the ID cards that informed low-income households of their eligibility and how much rice they were entitled to receive. They also randomly selected 194 villages as controls that did not get the ID cards. They then compared the rate of receipt of the subsidized rice by the treatment villages and that of the control villages to see if the cards made a difference. And they did. Households that received the cards saw a sizable increase in the quantity of rice they received through the program compared with households in control villages that didn't get cards. And rice delivered to ineligible families did not go up. The government of Indonesia was so impressed with the results that it scaled up the ID card program to all eligible households nationwide. The gold standard of testing causation, powered by the flip of a coin, gave policymakers the data they needed to bring this beneficial program to over 15 million low-income households in the country.